Hello, my name is Justin Buckner with Sequatchie Concrete Service. Thanks for joining us today as we begin part 2 of our educational series. ASTM C138 is the standard test method for density, yield, and air content. Conventional concrete, normally used in pavements, buildings, and other structures, has a density range from 137 to 150 pounds per cubic foot. The density of concrete varies depending on the amount and density of aggregates, the amount of air that is entrapped or purposely entrained. There is a wide spectrum of special concrete to meet various needs. Their density ranges from lightweight concrete weighing around 100 pounds per cubic foot to heavyweight concrete weighing in excess of 250 pounds per cubic foot. Yield is defined as the volume of concrete produced from a mixture of known quantities of the component materials. It is important for the ready-mix supplier to verify yields to ensure the customer is receiving the correct amount of concrete. You must know the density of the concrete before you can calculate the yield. The density of concrete is also another verification of the air content in a sample of concrete. ASTM C231 determines the air content of a sample of concrete using a pressure meter. In the meter, you have a known volume of air at a known pressure in the sealed air pot, with an unknown volume of air being contained inside the sample of the wet concrete. You set it to the percentage of air, your initial pressure, where the pressure is equalized inside the chamber. Fill it with concrete and water so that the only air left is the air inside the concrete, and then release the pressure inside the air chamber to get your apparent air content. Air content is very important to the project engineer and the concrete supplier. The amount of air can increase or decrease the strength of the concrete, and it can determine whether the concrete is protected from freeze-thaw conditions or is prone to weathering, and it also can affect the finish or the cosmetic look of the concrete. For every percent of entrained air, the strength of the concrete goes down about 200 to 300 psi. Air content specifications should be determined during the pre-construction or pre-pour meetings. This method is used for regular weight concrete that has relatively dense aggregate. Lightweight concrete is typically done with the volumetric method because the aggregate is too porous, and the test results would be thrown off with so much entrapped air. Also, this test should not be performed with any concrete with aggregate larger than 2 inches. Large aggregate pieces should be sieved out before testing. Collect sample in accordance to ASTM C172. Moisten the bucket and remove excess water and zero the weight of the scale. Place the container on a flat, level, sturdy surface. Add first layer of concrete, rod 25 times. Tap the side of the bucket 10 to 15 times with a mallet. Add second layer of concrete and rod an additional 25 times. Tap the side of the bucket 10 to 15 times with a mallet. And third and final layer of concrete, fill about 1/8 of an inch over the top of the bucket. Rod 25 times. Tap 10 to 15 times with a mallet. Strike off the top, weigh the bucket and record the results. Clean bucket rim with a sponge, moisten the bucket seal, clamp lid in place. Ensure the petcocks are open. Fill the meter with water until it comes out of the other side. Fill the chamber with air to the initial pressure, and which is on this meter is 3%. Gently tap the gauge to make sure the air has stabilized. Close the petcock, press the release, tap the side of the bucket with a mallet, and take the reading. Report your reading to the nearest 0.1%.